The Webb telescope discovers a new galaxy, which could break our current physics. This is the recently discovered Schrödinger's galaxy that seems to be at two places simultaneously. Furthermore, it is the farthest ever captured galaxy. But how does it threaten our current existing models of cosmology? Let's find it out. I believe you know that light travels at a finite speed, and due to this, everything you look at is in the past. For example, if you are looking at a galaxy a billion light years away, it would mean you are seeing how it looked like a billion years ago. But because of the universe's expansion, the wavelength of that light increases by the time it reaches us, which we now know by another name, redshifting. Astronomers denote redshift by a dimensionless quantity, z. Z equals 0 represents present time. As its value increases, the look-back time and the distance to that celestial object also increase. One way to determine the redshift of the galaxy is by analyzing it in different standard color filters. This gives us the galaxy's photometric redshift, but unfortunately, it is not too reliable. The accurate redshift of a galaxy can only be found by studying its spectral lines. So the spectroscopic redshift is used for determining extragalactic distances. Previous to the recent discoveries, astronomers have confirmed the existence of only one galaxy in the Z greater than 10 era of the universe. It is a galaxy named GNZ11 and was found by the Hubble telescope in 2015. But galaxies having redshifts more than 12 cannot be observed by Hubble, and that's because of the wavelength limit of the instrument. What's more, Hubble can only look back up to 500 million years after the Big Bang. But Webb can go back further to up to just 200 million years after the big event. So Webb has given us an extraordinary view of the Z greater than 13 era that has remained out of our reach so far. Discovering galaxies between the redshifts of 13 and 14 is quite exciting for astronomers. In its first few weeks, astronomers have reported several clusters in that range. Everything was normal until this happened. A team of researchers reported a galaxy at a record redshift of 17. This galaxy has been officially named CIRS 1749, and it existed within the first 220 million years after the Big Bang. The bigger thing is its stellar mass. CIRS 1749 has a mass of 5 billion solar masses. But the main problem here is that this number is quite large, considering the time, which is 2 less. That's very puzzling to astronomers. It is 5 times the stellar mass of GLZ13, another galaxy discovered by the JWST at a redshift of 13.1. It is very challenging to produce such extraordinary luminous and massive galaxies only about 200 million years after the Big Bang. This graph plots the stellar mass threshold and the redshift of 4 remote galaxies. GNZ11 is the one discovered by Hubble, and GLZ11 and 13 were shown to us by the Webb. It can be clearly seen that CIRS 1749 lies in the region of the diagram that is in tension with the lambda-CDM cosmology. This lambda-CDM cosmology tension area shows how much the stellar mass shall be considering the amount of Z, the redshift. If this galaxy is spectroscopically confirmed and more of them are discovered in the tension region, it distinctly states that it may provide a compelling hindrance on cosmology. Well, for those who don't know what this is, the lambda-CDM cosmology is the short form of lambda cold dark matter cosmology. It helped astronomers determine the accelerated expansion rate of the universe. I'll explain the lambda-CDM model in another video. So moving on, another thing they calculated was this galaxy's star formation rate. And it was about 34 solar masses per year. That is almost 100 times that of the Milky Way, meaning the galaxy probably had an intense burst of star formation activity. Forget stellar mass. Another strange parameter of the CIRS 1749 is its UV brightness, or the absolute ultraviolet magnitude, the MUV. The absolute UV brightness of an object is its brightness as placed 10 parsecs away. The lower this number is, the brighter and more luminous is the celestial object. Ceres 1749 has a MUV of -22. This shows that the galaxy is exceptionally luminous. Such high UV luminosities were never expected for a system lying a mere 220 million years from the Big Bang. This parameter indicates that something isn't right with our cosmology models. That's because Ceres 1749 is not the only one with such a high luminosity in the Z greater than 10 era. Even HD1, the most distant galaxy candidate discovered by ground-based telescopes, has a MUV of -23. So, if confirmed at Z equals 17, Ceres 1749 would be one of the most luminous galaxies at Z greater than 10, second only to HD1, and comparable to the spectroscopically confirmed GNZ11. Alright, but why is this galaxy known as the Schrodinger's galaxy? Although observations strongly support that this galaxy lies at a redshift of around 17, there is a non-zero probability of a Z equals 5 solution being true. The analysis of this galaxy strongly favors the Z equals 17 solutions, but researchers chose not to rule out the accompanying possibility. And that's why they have nicknamed this candidate Schrodinger's galaxy, that seems to be at two places at once. It is related to the famous Schrodinger's cat that's dead and alive both until you observe it. This candidate lies at Z equals 5 comes from its local environment. Its three nearest neighbors all lie at a redshift close to 5. Next, the researchers determined the stellar mass of one of the neighbors, and it came out to be about 100 billion solar masses. So if Ceres 1749 lies at the same redshift, it may be a linked satellite galaxy of its massive neighbor. That's similar to the Magellanic Clouds and the present-day Milky Way. The Magellanic Clouds have a stellar mass of 1 billion solar masses, and the Milky Way, on the other hand, 100 billion solar masses. Okay, so if Z equals 5 solution is accurate, there is no problem in our current cosmology models, right? No. Even if this galaxy is confirmed to lie at a redshift of 5, it challenges our cosmology models. That's because a Z equals 5 solution limits its star formation rate just to 0.1 solar masses per year. That's about 3% that of the Milky Way. So in that scenario, it would be the most distant quiescent galaxy found to date. What is a quiescent galaxy? Quiescent galaxies are the systems that are characterized by number 1. Their large stellar masses and sizes. Number 2. Several billion years old stellar populations. Number 3. Red colors. Number 4. Little to no active formation of new stars. And number 5. Very limited amount of cold gas and dust. So finding such quiet galaxies at high redshifts of about 5 challenges our current understanding of galaxy evolution. There is more than a 90% chance that this galaxy lies at a redshift of about 17. Spectroscopic follow-up of this remarkable galaxy is critical to Webb's mission. The James Webb Space Telescope has finally unlocked the last unknown era of our cosmic timeline. And undoubtedly, we can't wait to find out what lies there. Comment down your opinions. I hope you enjoyed this video, and if you did, don't forget to hit the like button, subscribe plus ring the bell for more such videos. And until next time, thanks for watching.